A solid is that form of matter which has a definite mass, a definite shape and a definite volume. The food will be tasteless without table salt or NaCl. This table salt has a definite molecular mass of 58.5 grams per mole. It has a definite geometrical shape of a simple cube. This cube has an edge length of 0.564 nanometers. Therefore, it has a definite volume of 1.79 into 10 raised to the power minus 23 centimeter cube. A diamond present in a ring, or how about a graphite present in pencils and kitchen utensils made up of metals. They all constitutes example of a solid and are important source of living. So let us learn about the first chapter, solid state. But before going deeper into the concept, we will first give you an overview about the topics to be covered in solid state. We will start with the basic properties of solid, followed by its types such as crystalline and amorphous solids. We'll further discuss about the various types of unit cells and Bravais lattices. Further, we'll look into the close packing arrangement of constituent particles and their packing efficiency in solids. We'll also discuss the imperfections or defects present in solids, and finally we'll study about the electrical and magnetic properties of solids. So let us first learn about the basic properties of solid. In solids, the constituent particles are closely arranged and are in a constant state of vibration about their mean position. This is the reason that it is very hard to compress solids. Now the question arises, why do certain matter such as table salt, sugar and metals exist in solid state at room temperature? Why can't they exist in a liquid or a gaseous state? This is due to the forces that exist between their constituent particles. There are two opposing forces which decide whether a substance will be in a solid, liquid or a gaseous state. These forces are first intermolecular forces and second thermal energy. Intermolecular forces are the attractive forces which try to keep these constituent particles close to each other, while the thermal energy are the repulsive forces which keeps these constituent particles far apart from each other. Therefore, if the intermolecular forces of attraction is greater than the thermal energy, the substance will exist in solid state. However, if the thermal energy exceeds the intermolecular forces of attraction, the substance will convert into liquid or a gaseous state. Let me elaborate by using an example of ice cube. Ice cube is in a solid state below 0 degree centigrade of temperature. However, if I keep this ice cube at room temperature, which is 25 degrees centigrade, it will melt into water. Now, if I further heat this water at 100 degrees centigrade of temperature, the water will boil and finally convert into steam. Now, what's happening here is, when we increase the temperature, the thermal energy exceeds the intermolecular forces of attraction that exist between the constituent particles of ice. Therefore, ice first melt into water and then finally convert into steam. To summarize, the properties of solids are: solids have a definite mass, a definite shape and a definite volume. Solids are hard to compress. The constituent particles present in solid are closely arranged and are in a constant state of vibration about their mean position. The intermolecular forces of attraction is greater than the thermal energy in solids. With this, we end up the module.